The percentage mark in a weekly mathematics test can be modelled by P is equal to A minus B, brackets T minus C squared. Now you might recognise this as completing the squared form, where T is the time in hours spent revising for the test and P is a percentage mark for the test. A, B, and C are constant. Nathan finds that however much he revises, his maximum mark achieved when he does 4 hours revision. This maximum mark is 74. Nathan had a mark of 10 when he did not spend any time revising. Find the values of A, B, and C. Using the model, if Nathan revises for 50 minutes for a test, what mark will he achieve? And what is the maximum amount of time Nathan could have spent revising for the model to work? Okay, so we've got this model where P is equal to A minus B, brackets T minus C all squared. We know the maximum mark is 74 when T is equal to 4. Now, if you know anything about completing the square form, like this, when this is 0, A gives you the maximum that this function can be. So, 74 will have to be equal to A minus B times 4 minus C all squared. So the maximum mark value of the expression is A when T is equal to 4, because that makes that equal to 0, because when T is 4, we get 4 minus C is equal to 0, and therefore C must also be 4. Basically, you get the maximum mark when that's 0, and you get the maximum mark of A. So therefore, A is 74, and C is equal to 4. So needs your understanding of the finding the maximum using completing the square form. Right, when T is equal to 0 and P is 10, this will allow us to find B. We've got 10, and our value of A is now 74 minus B times 0 minus 4 squared. Minus 4 squared is 16, so we've got 10 is equal to 74 minus 16B. 16B will be equal to 74. I take 16B over here and 10 over here, we get 64, and therefore B is equal to 4. So our model is P is equal to 74 minus 4, brackets T minus 4 all squared. When T is equal to 50 minutes, T will be equal to 50 over 60 hours, okay, because this T had to be measured in hours. We need to convert this into hours. So that's going to be 5 over 6 hours, and we should leave that like that because we can use the fraction button on our calculator. So P will be equal to 74 minus 4 times 5 over 6 minus 4, all squared. And therefore we're going to get 305 over 9. He worked that out, which gives approximately 33.8. So he can possibly expect to gain 34 marks if he revises for 50 minutes under this model. Right, the model will be valid for P greater than 0 and T greater than 0 because we can't go backwards in time. So if we take our expression model, which is 74 minus 4, brackets T minus 4 squared, it has to be greater or equal to 0 because P has to be greater and equal to 0. We're not going to get negative marks. So we need to solve the inequality 74 minus T squared minus 8T plus 16 is greater than or equal to 0. So that gives me minus 4T, taking this in here, plus 32, minus 16, minus 4 times 16, plus 74. So I've moved the 74 over here. So that gives me minus 4T, plus 32, minus 64, plus 74 is plus 10. Multiplying by minus 1, it gives me 4t squared minus 32t minus 10, but we now need to remember to reverse the inequality sign because you're multiplying both sides by a negative number. Notice that 0 times minus 1 is actually 0, and these are all divisible by 2, so we get t squared, 2t squared minus 16t minus 5 is less than or equal to 0. So using the quadratic formula to find the critical values, we're going to have minus 16 plus or minus b, which is minus 16 squared. Make sure that goes in brackets. Minus 4 times 2 times minus 5 over 2 times 2. That gives me 16. 16 squared is 256 plus 4t over 4. Don't make sure that minus sign stays in a bracket, otherwise you'll put here minus 256 and it won't work for you. And then we're going to have 16 plus or minus the square root of 256 plus 40, which is 296. So either t is equal to 16 minus square root of 296 over 4. Well, that's not possible because this is actually negative. We can't actually go backwards in time. Or t is equal to 16 plus square root of 296 over 4. This is possible because it's positive. So there is the model will be valid from t being greater than 0 or equal to and less than or equal to 16 plus square root of 296 over 4. So the maximum, this is the maximum value, so we need to find out what value that gives me. So on my calculator, converting that to a decimal, we get 8.301 hours. And then 0.301 hours times 60 is approximately 18 minutes. So the maximum time will be 8 hours and 18 minutes. Okay, here is a graph of the model. So this is the model. We can see it's a quadratic with a minus x squared. Okay, we can see that the maximum score that we could get in this model is 74. If we do no revision, we know we can get 10. And we know that the model will be valid from this point here to this point here. Outside of this range, it's going to be negative. We can't have negative time or negative percentage. So it's only valid between these 2 points, 0 and 8 hours and 18 minutes. Okay, so this has been a video to show you how to model the revising time using a completed the square form, finding the constants. I hope you've understood, and I thank you very much for watching.